Have you ever wondered what's at the very heart of Jupiter, the colossal king of our solar system? For decades, we've pictured a small, super dense, rocky core, just like a bigger version of Earth's. It seems logical, right? A giant planet must have a solid anchor. But what if I told you that our understanding of Jupiter's interior is being completely rewritten, and the truth is far stranger and more fascinating than we ever imagined? For the longest time, the textbook model was simple: a small, solid core of rock and ice crushed under the immense weight of a metallic hydrogen ocean, which is then wrapped in a vast atmosphere of hydrogen and helium. It's a neat and tidy picture, but Jupiter, it seems, is anything but neat and tidy. The data sent back by NASA's Juno spacecraft, which has been gracefully orbiting Jupiter since 2016, is painting a picture that has left scientists scratching their heads. Juno isn't just taking pretty pictures, it's measuring Jupiter's gravity field with unprecedented precision. And these measurements are telling us something profound. The core isn't the small, distinct ball we thought it was. Instead of a solid, well-defined center, it looks like Jupiter's core is fuzzy or dilute. Imagine trying to mix oil and water, but on a planetary scale and under pressures millions of times greater than on Earth. The heavy elements that we expected to be neatly settled at the center, things like rock and ice, seem to be mixed and smeared out, extending up to nearly half of Jupiter's radius. It's not a solid lump. It's a vast, blurry region where the core gradually dissolves into the metallic hydrogen layer above it. So, how could this happen? One leading theory points to a cataclysmic event early in Jupiter's history. Imagine a young Jupiter, just forming, being struck by a massive protoplanet, a baby planet, perhaps 10 times the mass of Earth. Such a colossal head-on collision would have been powerful enough to completely shatter Jupiter's original, primordial core. The impact would have splashed the core's dense material, scattering it and mixing it into the overlying hydrogen and helium layers like a cosmic blender. Over billions of years, this scattered material hasn't fully resettled, leaving behind the fuzzy, diluted core that Juno is detecting today. It's a dramatic and violent backstory for the gas giant. This changes everything. If the core is this sprawling, mixed-up region, it affects how heat flows from the interior of the planet. This, in turn, influences Jupiter's powerful magnetic field, the strongest in the solar system, and even the weather patterns we see on the surface, like the famous Great Red Spot. The planet is a single, interconnected system, and a fuzzy core means the engine driving it is fundamentally different from what we assumed. But there's another, equally mind-bending possibility. What if Jupiter's core isn't solid at all? Forget a fuzzy, mixed-up solid. Imagine a primordial soup or a slushy, swirling ocean. Under the crushing pressures and searing temperatures at Jupiter's center, we read talking pressures up to 50 million times that on Earth's surface, and temperatures hotter than the surface of the Sun. Our traditional definitions of solid, liquid, and gas breakdown. In this environment, elements we consider solid on Earth, like iron and rock, could exist in a bizarre state. They might dissolve into the liquid metallic hydrogen, creating a vast, churning ocean of elements. It wouldn't be a solid ball, but a dynamic, convecting fluid. Think of a lava lamp, but the size of a planet and made of materials we can barely comprehend. This soup core would be a swirling vortex of rock, ice, and hydrogen, all mixed together in a state that has no direct equivalent on our own world. Why is this so hard to confirm? Because we can't see it. No probe, no matter how advanced, can survive the journey to Jupiter's core. The pressure and temperature would vaporize any spacecraft long before it got anywhere near the center. It's a realm that is completely inaccessible to direct observation. All we have are indirect clues: Juno's gravity measurements, seismic waves or Jovian quakes that ripple through the planet, and complex computer models that try to simulate these extreme conditions. It's like trying to figure out the shape of a bell-esque clapper just by listening to the sound it makes from miles away. This deepens the mystery of how giant planets form in the first place. Did Jupiter start with a solid seed that grew by collecting gas, as the traditional core accretion model suggests? Or did it form rapidly from a direct collapse of a cloud of gas and dust, similar to how stars are born? A fuzzy or liquid core might favor the giant impact theory, or even suggest that our models of planet formation need a major overhaul. Jupiter, being the biggest, is our best laboratory for understanding this process. The implications are huge. If Jupiter's core is a slushy mess, then what about Saturn? What about the hundreds of gas giants we've discovered orbiting other stars? We often use Jupiter as the blueprint for these hot Jupiters and other giant exoplanets. If our blueprint is wrong, our understanding of these distant worlds could be fundamentally flawed. We might have to rethink the internal structure and evolution of countless planets across the galaxy. The idea of this unseen interior, this swirling, slushy ocean of elements under unimaginable pressure, is a powerful reminder of how much we still have to learn. Jupiter isn't just a static ball of gas, it's a dynamic, evolving world with a chaotic history and a core that defies our earthly intuition. The Juno mission is scheduled to continue its observations for a few more years, gathering more data with each close flyby. Each orbit brings us a new piece of the puzzle, refining our models and getting us closer to understanding what truly lies in the heart of the giant. The next time you look up at the night sky and spot that brilliant point of light that is Jupiter, remember what's hidden beneath its swirling clouds. It's not a simple, solid heart, but a vast, mysterious, and chaotic engine room, a fuzzy, slushy, primordial soup that holds the secrets to the birth of worlds. It's a universe of possibilities hidden deep within a planet right here in our own cosmic backyard. Thank you so much for joining me on this journey to the center of Jupiter. If you found this as mind-blowing as I do, please hit that like button and don't forget to subscribe for more deep dives into the mysteries of our universe. Let me know in the comments what you think is a Jupiter's core shattered solid or a swirling ocean. I'd love to hear your thoughts. Until next time, keep looking up,